Well, I'm Simone, hello, and together with Andrea, that is my colleague in Abies Project, we developed this, let's say, project for selecting wood. My background is in physics. I studied physics at university, and then I took a PhD working on nanomaterials, basically, for optical application. I'm still working in the, let's say, in the field now on semiconductor, but let's say I spend a lot of time working with materials for building instruments. I build instruments by myself together with Andrea in our shop, and my master is Chris Jenkins from Texas, from Leigh Morse, and in the last 10 years we were working together building guitars, and just before COVID time was 2019, together with other two luthiers like Michael Bashkin and Richard Jowen from Wyoming, and Chris, of course, we start developing this project for selecting wood based on acoustical and mechanical properties of the wood. We are so lucky since our workshop for building guitars is just 10 minutes driving from Rivolta. So this was the reason why we started this project, since our friends from the US were asking wood from here, and we were selecting wood for them, and we were finding a way to select the best wood as possible for them. And so talking with them and also studying a lot about acoustic properties of wood, I will mention mainly Trevor Gore book, we ended up with a system for selecting the soundboard, guitar soundboards. So we start from thousands of tops here, since we have access to all the Rivolta warehouse from Val di Fiemme Valley. We ended up, let's say, putting wood on that shelf, and I will say that just a few % of those thousands of tops we select every year end up in the shelf, since our selection is very, let's say, picky. We start from something like this, so from pallets with hundreds of tops per pallet, and the first part of the process is, let's say, visual inspection of the soundboard. So from the soundboard we can evaluate, let's say, the quality of the soundboards in terms of, let's say, grains. We try with the light to evaluate as much as possible the presence of runout, and we can evaluate the quarter zone, and how the grains are, let's say, straight or waving, or if they are even, how wide they are, and we can start having a first feeling on the density of the wood. And after that, we decide, let's go on with the selection of this piece of wood or just discard it. And this is a pretty, let's say, we select just a few of those. So maybe from a pallet like this, we just end up with, I don't know, 50 tops or something like that. The second step of the process is the measurement of the dimensions and the mechanical properties of the material. So we typically, let's say, measure the dimension of it. So the width, the length, the thickness in different points, so we can average the thickness, and then we weight it. So we have, let's say, immediately the density of the wood. And density is an important parameter for us, since Italian alpine spruce is well known for being lightweight, and lightweight means that we are typically in between 350 up to 400 kilograms per cubic meter, so it can be very lightweight. And after that, we want to have information about the mechanical properties of the wood. And we mainly look for the long grain stiffness, so the long grain Young modulus, and we measure that with a frequency method that is a well-known procedure. So basically, to measure that, you need a calibrated microphone and an FFT analyzer. And to do that, the method is to hold the piece of wood on the antinode of the vibration of the material, that for a piece of wood like this, the antinode is at the 22% of the length. So you measure the length, you calculate the 22% of the length, and you hold the piece of wood there. So in that way, if you tap the center of the top, then you are exciting the wood in the node, and so you are exciting the longitudinal mode of vibration. And if you do that in front of a calibrated microphone, you will see the presence of a peak in the spectrum. This is an FFT analyzer, it's a free software. There are many different, this is the REW software, REW, and you can measure the frequency of the longitudinal mode. And then from the frequency of the longitudinal mode, knowing all the dimensional properties and the weight, then you can retrieve the Young modulus that gives you an information about the stiffness and the longitudinal direction of the wood. And other things that we can then calculate starting from density and the Young modulus is the sound radiation coefficient that is, let's say, a coefficient that gives you let's say a feeling on how loud is, let's say, how loud can be this soundboard. So how it is efficient, this piece of wood to emit sound starting from the mechanical vibration of the wood. We do this process for every piece of wood that we select. And we put a serial number on the soundboard. So every piece of wood that we have are then stamped, and we put a serial number on that. And we make the data that we collect available to customers. So when a customer chooses the soundboard, have all the data available. So, but how to use the data? This is a tricky point, but is probably the most interesting one, since the reason why we are doing that is that we were providing at the beginning soundboard to our friends, Luthier friends in the US, and so they were looking for some specific, let's say, properties of the wood, like the stiffness, like the density, since if you start building, knowing this data, you can, let's say, design your guitar based on these properties. Since, let's say, Young modulus, longitudinal stiffness, is the most important one of the stiffness of the soundboard that tells you, let's say, how you will end up in frequency response. And the same for the density, since basically we are talking about an oscillating system that is defined by stiffness and density. So if you know the properties you are starting from while building, you can also design your guitar. This looks easy, it is not, since a guitar is, let's say, a complex system, and you also have to pair these with, let's say, a bracing system, and let's say the shape and the presence of sound holes. So it's not straightforward, but you can use this data together with, let's say, your, let's say, design to end up with, let's say, an intentional design of the spectrum response.
So Simone, is it possible that you find a piece of wood, let's say in the single A or the double A pile, that after you do your testing, visually perhaps it's not advantageous, but sonically it's like, wow, I can use this?
Absolutely, yeah, it does happen, sure. Since, as Stefano told before, the inspection that they do here at Rivolta, but as in many other wood suppliers, are, let's say, mainly based on the aesthetics of the wood. And this is not directly related to the acoustic properties. Since maybe you have, let's say, grains that are darker, so it is not fancy, it's not completely clear, the soundboard, but the acoustic is still there. And so you can have, let's say, very high, very low density, or very, let's say, high stiffness, or very high SRC, even if the soundboard is not looking great. And I think this is a good part of our process, that we can select very top quality in terms of acoustics and mechanics soundboard, even if they are not best looking. For example, we have customers that are not looking for the most fancy one, since they do, let's say, dark color or sunburst. So they hide these aesthetic cosmetics problems. And so they still can have very high quality tops in terms of acoustics, even if they are not good. And they can save also some money, since you start from a lower grade wood, but we added value with this acoustic measurement, yeah.
And do you ship worldwide?
Yeah, we ship worldwide, and we work in collaboration with Rivolta about shipping, since it's not that easy sometimes, since shipping overseas, for example, it needs certificates, phytosanitary certificates. So we partner with Rivolta also to provide all the documents that are needed for shipping worldwide. Yes. Okay, so we started selecting, let's say, pristine wood from Val di Fiemme, and in the last year we started also selecting some thermo-treated wood. You can see big difference in color, and there is, let's say, a thermo-treated process on this wood. You can see from here, we label this with this fire logo, and we perform different types of thermo treatment together with Rivolta from an external supplier, and we found that, let's say, a good thermo treating process that gives this wood properties that are good both in terms of acoustics, but also in terms of stability of the wood, and being the wood not brittle, that is a typical problem from some, let's say, strong heat treatment. And so we measure the properties of the wood, and on average is very interesting. And together with Martino Quintavalla, that is a luthier here in Italy, that is working on, is building mandolins and is acoustical and material engineer, we are also going to publish a paper on this, on the properties of the thermo-treated wood.
So just a quick question.
Yeah.
The advantage of thermally treated wood.
Yeah.
So just makes it lighter, makes it more stable. That's it. Acoustically, is it better?
Well, better, you know, as I was telling before, what we do is to collect data. So in our, let's say, website, you will see that we have a very big variety of properties. So lightweight, let's say heavier, and then stiff, less stiff, because we don't want to say this is the best wood. These are the best properties. We want to allow the customer, the luthier, to decide by himself because different luthiers build in a different way and they need different kind of wood. So we don't want to say what is the best. Of course, we have an acceptance range and we try to, we select within that acceptance range, but it is quite wide. And the same is for the heat-treated wood. Since what we observed, and we will publish, let's say, the data in a very detailed way in the paper, basically, yes, it's lightweight, more lightweight, but not much. And so density is lowering a little bit. But what we measure that is changing a lot is the damping. And again, low damping, high damping, what is better? I don't know. It depends on what you are building, since low damping can be critical in some type of buildings. So again, I don't want to say that it increased the acoustical properties, but for sure I can tell that it is changing. This treatment is changing the acoustical properties of the wood.
So as a luthier, what would you choose for a certain type of instrument? For example, classical, what would you choose? Low density or high density or et cetera? And what would you choose for a steel string?
Yeah. Well, me and Andrea builds acoustics, so I'm not an expert of classical guitars building, but we have a lot of customers building classical guitars. And what I can say is that they are mainly focused on the lightweight soundboard and not, let's say, stiff, but not too stiff. Because you have to know that, let's say, the stiffness and the density are somehow related. There is, let's say, the stiffer the denser, on average, of course, is a kind of scattered plot, so it's not... but I will say that they are mainly looking for low-density tops for classical guitars. While for steel strings, it really depends on the type of guitars that you are building. Since we have customers building kind of dreadnought or, let's say, some Martin replica that are looking for heavier tops, stiffer tops. But for example, in our case, that we build, let's say, high responsive guitar for fingerstyle. We mainly target, let's say, average stiffness and low density and high sound radiation.
So if people visit your website, can I choose that exact piece of wood, for example, you have in your hand?
Yes. So in our website, we put, let's say, high resolution photograph of each soundboard. And Andrea, my friend and colleague, is, let's say, a professional photographer. And we have, let's say, a photographic booth, and he does these very nice, let's say, photographs. So you can see all the details of the soundboard that you are going to buy. And together with the photo, you have for each soundboard the data. So again, dimensional things, let's say weight, density, sound radiation coefficient, Young modulus. So, and ear also, yeah, of course.
So if somebody doesn't have enough information, for example, about what they want, can they contact you and say, this is what I want to build? Will you recommend certain characteristics?
Yeah, that's why, let's say, in our website is not really an online shop. You can go there. There is a showroom where we have all the soundboard, and then you can request for soundboard. And this is a way that we like because we have a very straight, tight contact with customers. And so it's quite typical for us to talk with our customers and to see which are their needs. And then we have now customers that are buying, let's say, for the second or third time, and they typically knows now what they want, and they go directly, they target directly the specs that they need. Yeah.
Do you ship small orders, just 1 or 2 tops?
Yeah.
Or do you prefer 1,000?
We prefer 1,000, of course, but we can ship also, let's say, small orders is no problem. Absolutely. Take a look to our website and contact us since we are available for any, let's say, help or suggestion or just question. So,
Give your website.
Yeah, our website is woodentones.com. It's like this.
There we go. Woodentones.com.
And we also provide, let's say, bracewood. In this case, we measure just the density right now. We want to set up something for measuring, let's say, Young modulus of the bracewood. And again, is Italian Alpine spruce from Val di Fiemme. So it's kind of typical for our customers to pair, let's say, soundboard with bracewood.
Thank you very much. Simone and Andrea, thank you. This has been a pleasure. Thank you.
Yeah, Andrea, come.
Yes, please.
Just to say hello.
Thank you.
So thank you, Robbie.